Okay, students. I'm going to try to fly through this with as clear of explanation as I can, but as concisely as I can to not waste your time. So, here we go. Number one. Is this thing? There we go. I'm trying a different stylus today, so we'll see how this works. So, which shows accelerated motion, and how do you know? Okay, by accelerated motion, what do we mean? We mean that the velocity is changing. So accelerated motion means the velocity is changing. So when you look at graph A and graph B, how do you know which one is showing a velocity that changes? Well, what do we know about the position time graph? The slope of a position time graph is velocity. Describe that slope. Constant. Constant slope. Constant slope on a position time, no acceleration, right? That's constant velocity. This graph, because these lines look identical. That graph looks just like that graph. But this is a velocity time graph. Velocity time graph, the slope on this graph is what? Acceleration. Remember, the slope of a position time graph is velocity. The slope of a velocity time graph is acceleration. So what's happening to the velocity values here? Starting at 0, and the velocity values are going up. They're increasing as time goes on. So, which one's acceleration? B. Has to be acceleration because the velocity is going up as time goes on. So in terms of your explanation, I mean, you could just say that the line going up on the VT graph means the velocity is increasing as time goes on. That's what acceleration is, and that's how you know. You know this one isn't acceleration because a constant slope here means that your position change is happening consistently, which gives us a constant velocity. Constant velocity, not accelerating. All right, number 2. Now, I'm not going to write anything out, I don't think, just because it'll save time, and so you may just have to go back and listen to what I said over again. So your explanation here, again, is that the line on a VT graph that goes up, that has a slope, means the velocity is changing. Changing velocity means acceleration. All right, here. Which graph shows an object accelerating, and how do you know? Okay, so the same question, basically. Which one is accelerating? Is this showing acceleration, or is this showing acceleration? It goes back to our question we had before. The slope of the position time graph means velocity, right? Slope here means velocity. Slope here means acceleration. Maybe I should write this out. Maybe I should write that part out. Now again, you have to pay attention what kind of graph you're looking at. This graph, slope of this graph is velocity. On the VT graph, the slope is, oh boy, what on earth was that? Let's try it again. Slope equals, oh boy, acceleration. Okay? Now, with that in mind, and again, you have to remember that. Like, this was the big idea of the tumble buggy unit. This was the big idea, or is the big idea, of the unit we are currently doing. That the slope of the VT graph is acceleration. That's what it is. Change in velocity over change in time. The slope of the position time graph is velocity. The change in position over the change in time, that's what we call velocity. So, which one of these is accelerating? That's the same as asking which one has a changing velocity. It's asking which one has a changing velocity. Does this one show a changing velocity? What's velocity on that graph? Slope. Does this one have a slope that's changing? Does this show a changing slope? It's a curve, yeah? Do curves have a constant slope? No. And so again, if you think about your slopometer, if you put your pencil on the screen as you looked at these, hopefully you saw, let me see if I can move that around. Look at that. That's how steep the line is, the curve is at first. Here, that's how, boy, this is drawn pretty well. I think this stylus is going to be a winner. So that right there is showing you what? That the steepness at the beginning, very steep. As time goes on though, the steepness is getting less and less, which means the steepness or slope is changing. Slope is velocity. That means velocity is changing on this graph, A. We have velocity that's changing, which means we have acceleration. Now we haven't looked at the B graph yet. What is this showing? This is showing an object with a velocity at whatever this value is, and what is it doing? Not changing. It's staying the same value, not getting bigger or smaller. This is constant velocity. This has a slope of 0. There's no slope here. There's no steepness. And the slope is acceleration. No steepness means 0 slope and therefore 0 acceleration. This is not accelerating. This one is. And again, how do you know? How do you know? Because the curve, because the xt graph is a curve, which means its slope is changing, and its slope is velocity. So changing velocity means acceleration. Are you all hearing that? You know that this graph is showing accelerating motion because it is a curve, which means the slope is changing. And the slope is velocity, and a changing velocity is what we call acceleration. I hope you get that. All right, next slide. Oh boy. Okay, number 3. Which graph shows the object getting faster, and how do you know? Okay, now this is a little different because the first two questions were asking you to compare a position time versus a velocity time graph. Two completely different kinds of graphs. And now we see we have a position time graph and we have a position time graph. They're the same kind of graph. That's kind of important. Now, they both have curves. Because they both have curves, that means they both have acceleration. Right? They both are showing acceleration because they both have curves, which means their slopes are changing. Changing slopes means changing velocities. Changing velocities means acceleration. But they're asking specifically which one is showing an object getting faster. Well, now we need tangents. We need some tangents to the curve. This one, the beginning of the curve, not steep at all. The end, pretty steep. This one, kind of steep at the beginning. At the end, oh boy, that's bad. That's bad. That's bad. That's not bad, I guess. Okay. What are all my scribbles telling us? This one is not steep at all at the beginning. Not steep means 0 steepness. 0 steepness on this graph means 0 velocity. It's not changing position at the beginning. It's starting horizontally. That means no velocity. Now, very steep. Very steep. Now, it happens to be negative, right? It's tipped negatively, but it's still very steep. No steep, very steep. That means no fast, very fast. This one, pretty steep at the beginning. And at the end, it's not very steep. Not very steep at all. So this one's getting less steep. This one's getting steeper. So if we have one here that's getting steeper, what does that mean? Steeper means faster. Right? Are y'all following? So, which graph shows the object getting faster? A. How do you know? Because the curve is getting steeper. Now here's where the confusion lies, because the line's going down. And so people think, well, the line's going down, so it can't be getting faster. This one's got to be getting faster because the line's going up. Everybody, for position time graphs, what do we look at to know how fast something is? We look at the steepness. The steepness here tells us how fast. This one is getting steeper. This one is getting flatter. It's actually getting less steep. If it keeps going, it's going to be completely horizontal here at the end, which means it's going to stop. No movement, zero slope. I hope you're getting this. Oh boy, I hope you're getting this. Remember, when you're looking at how fast something is on a position time graph, you're looking at the steepness of the curve. All right, number 4. Which graph shows an object slowing down? Slowing down now. So now we're not talking about getting steeper. Back to number 3, I'm sorry. How do you know? Because this curve, it has to be A, because this curve is getting steeper. And getting steeper means the velocity is increasing, and that means getting faster. Steeper means faster. Okay? That's how you explain how you know. Not because of what the line is doing, but because of what the slope or steepness is doing. All right, back to number 4. Slowing down. Now we're looking at the same kind of graph, xt, xt. So we're looking at curves here. We have to figure out which curve is slowing down. That means which curve is getting what? Getting less steep. Because steeper means faster, that means less steep means what? Slower. We're looking at slower. Less steep means slow. Oh, what a bonehead. That's, nope. Less steep. Oh gosh. Whatever. Okay, less steep. Now we need some. Oh gosh, that was not great. I gotta turn this thing around. Oh my gosh. Oh. Okay, that's pretty good. Okay, at the beginning of this thing, that's how steep the curve is. In fact, it's probably a little steeper than that. At the end of it, the curve is like that steep. What does that mean? That means it was steeper. It was steeper at the start here than it was later on. Steeper here than it is here. What does that mean? That means it's getting less steep. Well, that's got to be the one then that's showing what we're saying. The object is slowing down. It was very fast in the negative direction. Now it's not as fast. Excuse me. I don't know if you can hear the wind in the video here, but my gosh, man, that wind is crazy outside. Where was I? The other one, just to check and verify. That's about how steep the curve is at the beginning. That's about how steep the curve is at the end. So this is way steeper than this one. That means this one's getting steeper. Getting steeper means getting faster. So this one's getting faster. This one was getting faster. This one is getting less steep. This one is getting less steep. So is that making, I hope this is making sense. You have to know, based on what's being asked for, you have to know what you're looking for here. Okay? All right, next slide. Oh boy. I may have to break this up into 2 videos, just so it's not so dang long. Anyway, where was I?